So today I'll be doing chapter 18, number 56b in our physics notebook. It states the 50 kilogram circular piston floats on 0.12 moles of compressed air. How far does the piston move if the temperature increased by 100 Celsius? So here is the diagram they gave us, and I just redrew it because it is a circular piston, so it's more of a cylinder shape than it is this rectangle, just to make it easier to imagine. So right here, all I did was I just changed the temperature because I know we're going to be dealing with the ideal gas law. So I just changed it to Kelvin. So it's increased by 100, so it's going to be 100 plus 30 Celsius. Then converting it to Kelvin, it will give you 403 Kelvin. So today we'll be dealing with two equations. The equations right here, which this is the volume of a cylinder, and then we're going to be using the ideal gas law. So it's asking how far it moves, so it's asking us for the height, so I just solved for height. And then so we have all these variables except the volume, and then we will get the volume using the ideal gas law. So I just solved for volume. So the first thing we have to do is solve for the total pressure. So the pressure on the piston is going to equal to the weight divided by the area. So it's going to be the mass times gravitational force divided by pi radius squared. So I just plugged in everything we know. We know that the mass is 50 kilograms. We know the gravitational constant, 9.81. We know pi, and then the radius is, if you guys remember, right here is 10 centimeters, so just divide that by 2 gives you 5 centimeters. So 5 centimeters converted to meters is 0.05 meters squared. So right here you get 62,452 pascals. So that is the pressure on the piston. And then we can't forget about the atmospheric pressure, which is 1 atm. So just converting that to pascals, you get 101,325 pascals. And that's something that's known, something that you could get in your book. So the total pressure is 163,777 pascals. All right, so now that we have that, we're able to solve for the volume. So we just plug everything we know. So we know the moles, we know R is a constant, so we know that. And then we know the temperature, 403 Kelvin. And then now we know the total pressure. You plug that all in, the volume you get is 0.00245 meters cubed. All right, so now that we know that, we're able to use the height problem, the height equation. So height equals the volume divided by pi r squared. So just plug in everything we know, the volume we solved, and we know the radius is 0.05 meters. So then the height we get is 31.2 centimeters. So at 403 kelvins, the height is 31.2 centimeters. But it does ask us how far does it move. It does not move 31.2 centimeters. In order to figure out how much it moves, you have to figure out the height it was at 30 Celsius. So I just did that really quick. So we're gonna use the same total pressure, the number of moles, the R constant, and now the temperature is the only thing that's going to change. So it's going to be 30 plus 273, giving you 303 Kelvin. And we literally just do the same exact steps. So we use the ideal gas law to find the volume. Just plug in everything in. And then we use the same height equation because it's still a cylinder, which gives you 0.235 meters, which is 23.5 centimeters. So at 303 Kelvin, the height is 23.5 centimeters. So to find how far it moved, the piston moved, it's going to be 31.2 minus 23.5 centimeters, giving you 7.7 centimeters. So the piston moves 7.7 centimeters. So from 30 degrees Celsius to 100 degrees to 130 degrees Celsius, it moved 7.7 centimeters. And that is the final answer.